In this problem, we're presented with a question that asks us to provide the Lewis structure and electronic properties of the cyanide ion. So here we are, we've got an ion, and so we would still process this the same way as we did before. So that means I'd still want to count valence electrons. I'd get 4 from carbon, 5 from nitrogen, but I also get an extra valence electron because of the negative charge. So adding those all together, I get 10. Arranging the molecule means essentially just putting the carbon and the nitrogen next to each other because that's the only possible arrangement. Carbon next to nitrogen, whether that's vertical or horizontal, it doesn't really matter. Everything else we would do the same way. We would start by drawing a single bond between the two atoms and reducing the electron count by those electrons. I have 8 electrons left, so if I were to start to try to make octets with lone pairs, I would get to the point where I use all 8, leaving me with no valence electrons left, but I still don't have an octet on nitrogen. This is what leads me to know that I'm going to need to use double bonds or triple bonds. So I would start to erase some of those lone pairs, and I would use them to make multiple bonds. Nitrogen's starting to get a little bit better, but it still doesn't have an octet. So I need to do it again. This molecule or this ion ends up with a triple bond. And because it is an ion, I should go ahead and enclose it in brackets and put the charge on the outside of the brackets. I used up all the electrons. I've got octets everywhere. So I'm done with the geometry. I'm done with the Lewis structure. Okay, so the rest of this stuff comes pretty straightforward. One of the reasons is it's only 2 atoms, so the only possible geometry between 2 atoms is linear. There isn't any bond angles to consider, and the reason is that in order to have bond angles, you have to have 3 atoms. And since I only have 2, the bond angles are not applicable. Same thing with the next 2 items. You're having a situation, but it's because it's an ion. We wouldn't really say whether or not it's polar or nonpolar because it's an ion. It is a singular charge. It is a negative charge. So polar means separation in charge, and the word polar then really doesn't apply because there isn't a separation in charge in the sense that it's negatively charged. There is a charge. And so we would say not applicable there. And also then for intermolecular forces, we would say that really there's only ion forces. And so we could say that maybe if this ion was associated with a polar molecule, there would be ion dipole forces. If it was a nonpolar molecule, maybe it would be ion dispersion forces. Maybe if it were oriented with another ion, we could say there would be ion-ion forces. But in a collection of just cyanide, we would just say there's ion forces. We can, however, say that the hybridization of the carbon atom is sp hybridization. Usually we would want to say, we would want to think about that from, usually we're going to get that from the electron geometry. And since the electron geometry is linear, we can say sp hybridization. Now, what about the bonds? There is a triple bond. And so with a triple bond, we would say that one of the bonds in the triple bond is a sigma bond. And the remaining 2 bonds in the triple bond are pi bonds. So in order to fill this part out, we would say 1 sigma bond and 2 pi bonds. And that's it for cyanide ion.